All right, let's talk about something that's a real head-scratcher for a lot of developers, serverless security. On one hand, you've got this incredible promise of simplicity, right? No more servers to manage. But then you actually try to secure it and suddenly things can feel overwhelmingly complex. It's this exact puzzle, this paradox that we're going to dig into.
And this quote from a user on Reddit, it just hits the nail on the head, doesn't it? You jump into serverless to make life easier, but before you know it, you're wrestling with this massive web of configurations that feels like the total opposite of simple. That tension between the dream and the reality is exactly what we're going to unpack.
So this really gets us to the heart of the matter for this explainer. Is that whole idea of serverless simplicity just a myth once security gets involved? Or is there a way to navigate the complexity? Let's find out.
Okay, to really get this paradox, we first have to understand who's responsible for what, and that brings us to one of the most fundamental concepts in all of cloud security.
Take a look at this. This is the famous shared responsibility model, and it basically draws a line in the sand. Everything you see here in orange, that's on the cloud provider, say AWS. They handle the heavy lifting, the physical data centers, the hardware, the core execution environment, the actual cloud. But everything in blue, well, that's on you. That's your code, your configurations, and how you manage access.
To put it as simply as possible, the provider secures the cloud, but you are responsible for securing what's in the cloud. They've got the servers covered, but your code, that's your turf. And truly getting this division of labor is the first, most important step to demystifying serverless security.
So, let's zoom in on your side of that line. Now that we know what we're on the hook for, what are the actual, concrete things we need to do to lock down our serverless functions?
Think of this as your must-do security checklist. You've got to validate every input, because you never know where a trigger is coming from. You have to watch your third-party dependencies like a hawk, lock down your storage and your secrets, and of course, handle off. But I want to double-click on one of these that is just so critical in the serverless world, and that's the principle of least privilege.
The principle of least privilege. This is huge. I mean, it's always important, but in serverless, it's on a whole other level. Think about it. Your app might be made of hundreds of these tiny functions. It's so tempting to just give them a generic, powerful role to save time, but that's a massive risk. If an attacker gets into just one of those overprivileged functions, they could have the keys to the kingdom. So the rule is simple, but crucial. Give each function only the permissions it absolutely needs to do its one specific job. Nothing more.
Okay, so we've got our responsibilities down. Now let's pull back the curtain and look at what the cloud provider is doing for us, the really sophisticated stuff happening on their side of that line. This is where the real magic of serverless isolation happens.
At the heart of all this is a technology called Firecracker. It's an open-source tool built by AWS specifically for serverless. Now, instead of firing up a big, clunky virtual machine, Firecracker spins up this super light micro VM for each function. What that gives you is a hardware-level security boundary, and it does it in milliseconds. It's pretty incredible.
And this diagram really shows you the power of that approach. On one physical server, you could have code running from completely different customers, customer A, customer B, side by side. But each one is totally sandboxed inside its own little micro VM, with its own kernel, its own resources. They have no idea the other even exists, which gives you incredibly strong security guarantees.
And it's not just Firecracker working alone. The platform is using a whole toolbox of battle-tested Linux security features to lock things down. You've got cgroups to limit CPU and memory, namespaces to keep processes separate. It's this defense in depth, this layered approach, that makes the underlying platform so trustworthy and robust.
All right, let's zoom back out a bit. We get our responsibilities, and we know we can trust the platform's security. So how do we actually manage all of this day to day? How do we make sure our own configurations stay secure as things change and evolve?
Well, the industry's answer to that is a class of tools called Cloud Security Posture Management, or CSPM. You can think of it like an automated 24/7 security guard for your entire cloud setup. It's constantly scanning for misconfigurations, things like a function with way too many permissions or an API gateway that's wide open, and it alerts you so you can fix it before an attacker finds it.
So CSPM is the big picture strategy. Now, let's get tactical and look at a very specific and very common type of misconfiguration a CSPM tool would catch, leaving your network access too open. So let's imagine you've got a function, and it only needs to talk to other things inside your own private network, like a database or some cloud storage. There is absolutely no reason for that function to be reachable from the public internet.
The way you fix this is with private endpoints, which essentially gives your function a private network address inside your own virtual cloud.
And look how straightforward this can be. Just a few clicks, you flip Enable Public Access to Off. You turn on private endpoints, and boom, you've just slammed the door shut on the public internet. All the communication now happens over your secure private network, which dramatically shrinks your attack surface.
And this really gets to the core mental shift we all have to make with serverless security. In the old world, we were guards at the gate. We patched operating systems, we configured firewalls, we built a big wall around our network. But in the serverless world, the whole game has changed. The focus moves up. It's not about the servers, it's about the code, the IAM roles, and the event triggers. The perimeter is no longer the network. It's the identity of every single function.
And that leaves us with a really big, thought-provoking question to chew on. As the infrastructure just vanishes from our view, as the cloud providers handle more and more of it for us, are we heading to a future where that line between infrastructure security and application security just completely disappears? A future where, for us developers, it's all just security. It's a fascinating thing to think about as we build what comes next. Thanks for joining me.